Welcome to our exploration of linear kinematics in human movement. In this video, we'll break down the essential concepts that describe how our bodies move in space and time. Kinematics focuses on the shape, form, and sequencing of movement, providing both qualitative and quantitative insights. Whether you're an athlete, a student, or simply curious about biomechanics, understanding these principles can help you appreciate the complexity and beauty of human motion. Let's embark on this journey to uncover how kinematic variables interrelate and shape every step, jump, and stride we take. Kinematics is the study of movement with respect to time. It describes the appearance of motion, focusing on how objects or bodies move rather than why they move. This includes analyzing the shape, form, and pattern of movement. Kinematics can be approached both quantitatively, using measurements and calculations, and qualitatively by observing and describing motion. By understanding kinematics, we gain insight into the mechanics behind everyday activities, sports, and even rehabilitation processes. This foundational knowledge sets the stage for deeper exploration into the mechanics of human movement. When we talk about kinematics in the context of human movement, we're often referring to form or technique. This means looking at how a person moves, the sequence of their actions, and the patterns they create. Whether it's a runner's stride, a dancer's leap, or a swimmer's stroke, kinematics helps us break down these movements into understandable components. By analyzing technique, coaches and therapists can help individuals improve performance, prevent injury, and enhance overall movement efficiency. Linear displacement is a key concept in kinematics. It refers to the change in location of an object or person, measured as the directed distance from the initial to the final position. Unlike distance, which considers the total path traveled, displacement is concerned only with the straight line difference between 2 points. This makes displacement a vector quantity, meaning it has both magnitude and direction. In biomechanics, understanding displacement helps us analyze how efficiently someone moves from one place to another. It's important to distinguish between distance and displacement. Distance measures the total length of the path traveled, regardless of direction, while displacement measures the straight line distance from start to finish. For example, a figure skater may travel a winding path across the ice, but their displacement is simply the direct line from their starting point to their ending point. This distinction is crucial for accurately analyzing movement in sports and daily activity. Linear speed is another fundamental kinematic variable. It is a scalar quantity, meaning it only has magnitude and no direction. Speed is calculated by dividing the distance covered by the time taken. In biomechanics, measuring speed helps us understand how quickly someone or something moves, which is essential for evaluating performance in activities like running, cycling, or swimming. In analyzing running speed, two key variables come into play: stride length and stride frequency. Stride length refers to the distance covered in one stride, while stride frequency is how often strides are taken within a given time. Together, these factors determine overall running speed. Improving either stride length or frequency can lead to faster performance, but optimal balance is necessary for efficiency and injury prevention. Running speed isn't determined by stride length and frequency alone. Other factors such as muscle fiber composition, footwear, fatigue level, injury history, and the characteristics of the running surface all play significant roles. For instance, a runner with more fast-twitch muscle fibers may achieve higher stride frequency, while proper footwear can enhance both comfort and performance. Understanding these influences helps athletes and coaches optimize training and reduce injury risk. As running velocity increases, both stride length and stride rate tend to change. Research shows that elite runners adjust these variables to maximize their speed. By studying these changes, biomechanists can provide insights into optimal running techniques and strategies for different distances and conditions. This knowledge is valuable for athletes aiming to improve their performance and for clinicians working to rehabilitate injuries. Linear velocity is the rate at which an object's position changes over time. Unlike speed, velocity is a vector quantity, meaning it includes both magnitude and direction. In biomechanics, velocity helps us understand not just how fast someone is moving, but also in which direction. This is crucial for analyzing movements like sprinting, swimming, or cycling, where directionality can impact performance outcomes. Consider a swimmer moving in a river. The swimmer's velocity is not just determined by their own movement, but also by the current of the river. The total velocity is the vector sum of the swimmer's velocity and the current's velocity. This example highlights the importance of considering both magnitude and direction when analyzing real-world motion, especially in dynamic environments. Acceleration is the rate of change of velocity over time. It tells us how quickly an object speeds up or slows down. In biomechanics, acceleration is measured in meters per second squared. Positive acceleration means increasing speed, while negative acceleration or deceleration means slowing down. Understanding acceleration is vital for analyzing movements like sprint starts, sudden stops, or changes in direction. Acceleration can be positive or negative, depending on the direction of motion and the change in velocity. When an athlete speeds up, they experience positive acceleration. When they slow down, such as when stopping at the end of a sprint, they experience negative acceleration. Recognizing these changes helps in designing effective training programs and understanding the demands placed on the body during different activities. When an object's velocity remains constant, its acceleration is zero. This means there is no change in speed or direction. In human movement, maintaining constant velocity is rare, as most activities involve starting, stopping, or changing direction. However, understanding this concept is important for analyzing steady-state activities like walking or cycling at a constant pace. Velocity can be measured over different time intervals. Instantaneous velocity refers to the speed and direction at a specific moment, while average velocity is calculated over a longer period. For example, a sprinter's instantaneous velocity at the finish line may be much higher than their average velocity over the entire race. Both measures provide valuable insights for performance analysis and training. Negative acceleration or deceleration is common in many sports. For instance, a baseball player sliding into a base must rapidly slow down to avoid overshooting the target. This involves applying force in the opposite direction of motion, resulting in negative acceleration. Understanding how athletes control deceleration is crucial for improving safety and performance in high-speed activities. Kinematic analysis can be performed using quantitative or qualitative methods. Quantitative analysis involves precise measurements, such as timing a sprint or measuring stride length. Qualitative analysis, on the other hand, focuses on observing and describing movement patterns. Both approaches are valuable and often used together to gain a comprehensive understanding of human motion. Kinematic principles are widely used in sports to enhance performance. Coaches analyze athletes' movements to identify strengths and areas for improvement. By adjusting technique based on kinematic data, athletes can increase efficiency, reduce injury risk, and achieve better results. This scientific approach is now a standard part of elite training programs across many sports. Rehabilitation, kinematic analysis helps therapists assess movement limitations and track progress. By measuring variables like displacement, velocity, and acceleration, clinicians can design targeted interventions to restore function and prevent re-injury. This evidence-based approach ensures that patients receive personalized care tailored to their specific needs. Kinematic principles aren't limited to sports or rehabilitation, they apply to everyday movements as well. Walking, reaching, or even standing up from a chair involves complex interactions of displacement, speed, and acceleration. By understanding these basics, we can appreciate the remarkable coordination involved in simple daily tasks. Biomechanics, standard units are used to measure kinematic variables. Displacement and distance are measured in centimeters, meters, or kilometers. Speed and velocity are typically measured in meters per second, while acceleration is measured in meters per second squared. Using consistent units ensures accurate analysis and comparison across studies and applications. Kinematic variables can be classified as vectors or scalars. Scalars, like distance and speed, have only magnitude. Vectors, such as displacement and velocity, have both magnitude and direction. Recognizing the difference between these types of quantities is essential for accurate movement analysis and interpretation. Let's apply these concepts to a practical example, analyzing a runner's performance. By measuring stride length, stride frequency, and velocity, we can assess how efficiently the runner moves. Adjustments to technique, such as increasing stride length or optimizing frequency, can lead to significant improvements in speed and endurance. In swimming, velocity is influenced by both the swimmer's effort and external factors like water currents. By analyzing the vector sum of these velocities, coaches can help swimmers adjust their technique to maximize forward movement and minimize resistance, leading to faster lap times and improved efficiency. Acceleration isn't just for athletes, it's part of everyday life. Whether you're speeding up to catch a bus or slowing down to stop at a crosswalk, your body constantly adjusts acceleration to meet your needs. Understanding these adjustments can help us move more safely and efficiently in our daily routines. Biomechanical analysis, including kinematic variables, plays a crucial role in injury prevention. By identifying inefficient or risky movement patterns, interventions can be designed to correct technique and reduce stress on joints and muscles. This proactive approach helps athletes and everyday individuals stay healthy and active. Modern technology has revolutionized kinematic analysis. Motion capture systems, wearable sensors, and high-speed cameras allow for precise measurement of movement variables. These tools provide valuable data for researchers, coaches, and clinicians, enabling more effective training, rehabilitation, and performance optimization. To recap, linear kinematics involves analyzing displacement, distance, speed, velocity, and acceleration. Each variable provides unique insights into how we move, and together they form the foundation of biomechanical analysis. By understanding these concepts, we can improve performance, prevent injuries, and appreciate the complexity of human movement. Study of kinematics has real-world impact beyond the classroom or lab. From enhancing athletic performance to improving rehabilitation outcomes and making everyday movements safer, kinematic analysis is a powerful tool. As technology advances, our ability to measure and understand movement will only continue to grow. As we conclude this introduction to linear kinematics, remember that these principles are just the beginning. Future lectures will dive deeper into the mechanics of movement, exploring topics like angular kinematics and kinetics. Stay curious and keep exploring the fascinating world of biomechanics. There's always more to learn about how and why we move.